Yes, welcome back. It's GSFCUK.com, the Gloria Swanson fan club. I'm Mike Dawson. And as I said, for a few weeks now, I've been trying to get Jeff on the line. Someone gave me a book called, or lent me a book called Y=MC squared. And I think one of his last words were, don't read it before you go to bed. And having got involved in the book and really enjoying it, I got in touch with Jeff, one of the authors. And he's a Manchester guy as well. He's at the Oxford, at the university up the road there. And hopefully I've got him on the line now. Are you there, Jeff?
I am, yeah.
Fantastic, coming in loud and clear. It's great, as I say, that you're a Manchester guy as well. I mean, can I just ask you, how do you find yourself getting up in the morning and being involved in this kind of thing? How did your career start in physics?
Two questions. Right? Career started in physics in a strange way. I didn't like physics at school very much, and got into it because I was so bad at it that my dad got a mate from work to come and try and help me with my homework. Yeah. And the penny dropped, and from then on, I've just loved it more and more. So getting up in the morning is not difficult. It's especially with what's happening at CERN.
Yeah, because
a lot of what people don't like about science and physics in particular is the maths bit, and that is really, that's like the tools that you need in order to do physics. So it's like there's a lot of technique involved. So you've got to kind of learn your maths. It's a bit like learning your scales, I think, if you're playing the piano. You've got to do a bit of work. Once you've got that sorted out, then you can go on and really enjoy what the whole subject's about.
And you've gone on to try and take away a lot of that mystery with the book Y=MC squared, haven't you? I think anyway, having read it, that you can really get involved in it because it's in layman's terms. It's not very, very mathematical, is it?
And that was the idea. Yeah, it was to actually try, instead of just talking about some piece of physics and saying this is like really amazing or this is really brilliant, actually just try to help somebody who's not done much physics appreciate why it is that Brian and I really enjoyed doing physics, why we love doing physics. And you get that by doing it yourself. And so we picked a piece of physics which is about as remarkable as it gets, and at the same time doesn't actually require very much technical detail to get it. It can be explained fairly simply.
It doesn't, does it? But from my point of view, I loved the book, but there was a point where I had to kind of look away from the book and go, right, hang on, let me just get me head around this. Because is it possible you could explain to us E=MC squared in about 30 seconds, the basis of it? Because I know it involves quite a lot of build-up, doesn't it?
Yeah, well, the whole thing is, so it's the culmination of Einstein's theory of relativity. And Einstein's theory of relativity is essentially an attempt to, although Einstein didn't think of it like this, but this is the way we think about it now. It's an attempt to understand what is space and what is time, right? What are those concepts? What does it mean? And Einstein found that they're not what you think. In particular, if you go for a walk to the shops and come back, you actually age less than somebody who's sitting watching the telly. It's a tiny, tiny effect, a really tiny effect, so tiny that you could never detect that for people going ordinarily to the shops. But there are circumstances, so the faster you went to the shops and the further you went, the bigger the effect becomes. And another example, you age more quickly at the top of Mount Everest than you do at the bottom because you're further away from the centre of the Earth. So there's a connection between time ticking and the Earth's gravity. So there's something really weird about time and space.